Hello boys and girls, welcome to lesson 5-3, lesson 3, properties of operations. This lesson is found on page 367. A couple of words I really want you to become familiar with are these two, commutative property and associative property. We will learn what these are today and their properties or skills or concepts that we have to implement when working with properties of operations or just operations in general. Real world link. Driving. Miss Ricardo drives up and down her street to complete different errands. Some chores she has to do. Some of the places on her street are shown below. The number of blocks between the places are also shown. So we have her house. 2 blocks away, the library. 1 block away from that, the games galore, it's a game store. And 3 blocks away from that we have the football field. Suppose Miss Ricardo drives from home to the game store and back. From home to the game store and back. Write an expression for each distance. So from home to the game store, we're going to write an expression representing the number of blocks. So I know that she has to go at least 2 blocks to go there, okay, to get to the library, but then 1 more block to get to the game store. So that's 2 plus 1, right? And then back. On the way back, she has to go again 1 block and then 2 more blocks to get home. On the way back, it would be 1 plus 2. Oop, 1 plus 2. Overall, okay, she has to go 3 blocks one way and 3 blocks back. And you notice how we wrote them and not in the same order? Well, we have to understand, is this commutative property or associative property? Circle the property that illustrates in exercise 1. Okay, when we can change the order of addition, and this only applies to addition and multiplication, means we can change the order, but the product or the sum will not change, right? Because this will still give you 3 and this will give you 3. When you can change the order and it doesn't change the outcome, the product or the sum, we call that commutative property. Number 3. On Monday, Ms. Ricardo drives from home, stops at the library, and then drives to the football field. On Tuesday, she drives from home, stops at the game store, and then drives to the football field. Write an expression for each distance. Okay, let's see. Monday, I'll draw it out. She drives from home and stops at the library. Alright, that's her first stop. And then drives to the football field. 1 and 3. Okay, all the way down to the football field. Good. I know that from home to the library she has 2. So I'll go ahead and for Monday I know she has 2. But then she drives later on 1 plus 3. So I can write that as separately in another at a different time of the day. She drove 1 plus 3 blocks. Okay? And we can write it as so. But then on Tuesday she changed the order a little, didn't she? On Tuesday she drives from home, stops at the game store. So from home, stops at the game store, and then drives to the football field. And then she drives to the football field. Right? So she changed the order a little bit. Where she now did 2, right? She first did 2 blocks plus 1 on her first trip. So she does 2 plus 1 on her first trip. And then for the last leg of her trip, she goes another 3 blocks. So that's how it gets separated. Okay, as you can see here, boys and girls, we still have 2 plus 1 plus 3, or 2 plus 1 plus 3. But we're grouping them. Remember that we always do parentheses first. So here I'm grouping these 2 numbers so that I can get the 4 that she did here plus 2. She did 2 together and then 4 together after that. Or on Tuesday she did 3 together combined on the first trip, or the first leg of her trip, and then the second leg she did 3. Overall, when we group numbers like this, because here I'm going to end up adding 3 plus 3. Well, here I do 4 plus 2. When we group these numbers, we call this associative property. So a quick review. Commutative property means A plus B is the same as B plus A. It does not change the sum. Okay, so this is commutative property of addition. It does not change the sum if I change the order. Commutative property of multiplication is the same. A times B is the same as B times A. 7 times 3 is the same as 3 times 7, or 6 plus 1 is the same as 1 plus 6. Associative property of addition and associative property of multiplication work very similarly. You'll notice that now we're actually grouping, so we're going to do A plus B plus C, or A plus B, then later plus C. Okay? And when you end up adding them, they're going to equal the same. Over here we have 2 plus A plus 3, which is 11, so it equals 13. Or we could do 2 plus 3, which is 5, plus 8 is still 13. Over here as well, we have 3, but we do the parentheses 4 first. 4 times 5 is 20, times 3 is 60. Or we could do 3 times 4 is 12, 12 times 5 is still 60. So it does not change the outcome. Please review this table on your own, but all I want to address is that a property is a statement that is true for any number. The following properties are also true for any number. For example, multiplicative property of 0. Any number multiplied to 0 will be 0. That's an example. Go ahead and read these and look at the example. Okay, I hope you paused and you looked at them. One that I want to point out is multiplicative identity. Multiplicative identity means when a number is multiplied by 1, the product is that number. So that's a rule, always. Anytime you multiply a number by 1, it will always be that number. 5 times 1 is 5, 1 times 5 is 5, okay? And then additive identity, when 0 is added to any number, the sum is the number, okay? So 0 plus 9 is still 9, or 9 plus 0 is still 0. These are additive identity, multiplicative identity, and multiplicative property of 0. These are rules that always apply. Now you're probably wondering, why is this important? Well, when we're explaining and talking in class, and we actually talk about algebraic expression, and we want to tell one another how we did something, or how we do it, or how it should be done, we're going to use words like associative property of multiplication and so on. Look at this one. Name the property shown. You see how we group it here? When we group something 5 times n, or we can do 2 times 5, right, which equals the same thing. We call this associative. And what is the computation? It's multiplication, so it's associative property of multiplication. Okay? Let's do A and B. We can see that we're adding, so it's going to be something of addition. And we can see that we've taken 42 plus x plus y, or 42 plus y plus x. All we did was just change the order, but at the end of the day, it's going to equal the same thing, right? At the end of it all, it's going to equal. So this is commutative. Commutative is when we can change the order around and it doesn't change, okay? So we change the order, and this is commutative property of addition. Go ahead and copy that down. Okay, and then next we have addition again, and we can see that we have 3x plus 0. Remember, anything that's added to 0, you can look above in the page that you're working on, and this looks like it's going to be additive identity. When we add anything with 0, it's going to be that number, because we're really not adding anything. So this is a rule, and it's called additive identity. These are important to know, boys and girls. They will be on the test. Okay, you may wonder if any of these properties apply to subtraction and division. Well, if you can find a counterexample, an example that shows that a conjunction is false, the property does not apply. For example, if I can do 10 divided by 2, we know that's 5. But if I do 2 divided by 10, it's not going to work. Okay, I can't use commutative property. Okay, I can't use commutative property because 2 divided by 10 is going to be 0.2. Okay, so it doesn't work. Same with subtraction. I can't have 7 minus 2, which equals 5, or 2 minus 7 is going to equal now negative 5. And negative 5 and 5 are completely different numbers. Okay, state whether the following conjunction is true or false. This sentence right there. Is it true or false? Division of whole numbers is commutative. No, we just showed that we cannot divide. When we divided 10 divided by 2 or 2 divided by 10, we get completely different numbers. So here we have 15 divided by 3. Okay, it's not the same thing as 3 divided by 15. Okay, so division is not commutative. Okay, the conjunction is false. Okay, for the next one, the difference. Whenever we talk about the difference, we're talking about subtraction. Okay, so don't forget that, subtraction. So the difference of two different whole numbers, like for example, a whole number such as 8 and 2. So the difference between these two whole numbers is always less than both of the numbers. Well, it's always less. I know that if I subtract these two, I'm going to get 6. And yes, 6 is less than 8, but it's not less than 2. So no, this is clearly false. Okay? 6 is not less than 2. Remember to copy all this down as a key answer, and I'll know you watched the video because you'll put this not less than. This is a sign we have not used in class, but this means not less than. Okay, with the line through it. Go ahead and copy this down. This is part of the key answer. You can also put a star next to it. Okay, for example 3, we have Alana who's buying all kinds of stuff for $38, $14, $22, $16, and so on. And they want you to do some mental math to figure this out. Find numbers. Use associative property for numbers that work well together. You know that over here, 4 and 6 work well together, right? 4 and 6 will give you another 10. So over here you have 30, okay? And then you know that 22 and 38 work well together because you have the 8 and the 2, which will give you another 10. So this right here will give you a nice round number to 60. So you can use associative property, and you see that's what they did here. You see they worked 38 plus 22 works well to give you 60, and 14 plus 16, because 4 and 6 work well together to give you a nice rounded number, gives you 30. You see that? Lance made 4 phone calls from his cell phone today. The calls lasted 4.7 minutes, 9.4 minutes, 2.3 minutes, and 10.6 minutes. Use mental math to find the total amount of time he spent on the phone. Okay, let's look for friendly numbers. I know that 0.7 is going to go well with 0.3, and I know that 0.4 is going to work well with 0.6. Those are all going to give me nice rounded numbers. So I'm going to use associative property. And it looks like this. Okay, associative property, I group these two together because I know they'll give me a nice rounded number. And I know 4 plus 2 is 6, and then 7 and decimal 3 will give me one more, so that's going to be 7. Plus, I know that 9 plus 10 is 19, and this 0.4 plus 0.6 is going to give me one more, so that's going to be 20. Right? And in total it's going to be 27 minutes that he talked on the phone. Take a look at how in example 4 and example 5, they use multiple steps to, and the steps are identified: commutative property of addition, associative property of addition, and then it's simplified to solve these algebraic expressions. Let's try E together, okay? But please make note of the properties being used. Well, I have 4 times 3c times 2. I can flip these two around and do 2 times 3c. And I know that that's commutative property of multiplication. Okay, you see that? It does not change. It will not change my answer. But then I know that 4 and 2 don't have a variable, so those two can be multiplied into one another much easier, right? And I can get 8. So I can use associative property of multiplication and associate those two and do those two first. 4 times 2, and then later on times 3c. Correct? That's associative property of multiplication. Then I can simplify, right? I did 4 times 2 is 8. And then again times 3c, right? Once again, I have 8 times 3c. You remember this is 3 times c. Don't forget that, 3 times c. I can use associative property of multiplication and group the 8 and the 3, and then later on multiply the c. So I have 8 times 3. I've associated these two. I've grouped them, and then I separated it from the c. So 8 times 3 times c, associative property. And finally, I simplify. 8 times 3 is 24, and I don't know what c is, so I just include it back in. Remember, this is going to be the operation is multiplication. So my answer, final answer is 24c in a simplified form. When I know what term this is, I can just multiply it times 24, and there's my most simple, or my actual answer. Okay, but I don't know what c is. C can be amount of cash, it can be number of corns, whatever. Okay? Please leave the guided practice for class, and do the independent practice on your own, including the back.